The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hello everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们好，欢迎走进今天的课堂。化学诺贝尔奖得主，今天给大家介绍的是伯纳德·费林加。Today I will introduce you a Nobel Prize winner in chemistry, who is Bernard Feringa, for design and synthesis of molecular machines. The American film Fantastic Voyage in 1966 told us how a submarine was miniaturized and injected to a scientist's body, performing vascular surgery for him and save his life. 50 years later, people still haven't turned the science fiction into reality. But the prediction of movies are still being confirmed by many people. There's a scientist named Bernard Feringa who turned the science of fiction into reality. He was born in Netherlands. He won the Nobel Prize in Chemistry in 2016. His prize motivation was for design and synthesis of molecular machines. He shared the prize with Jean-Pierre Sauvage and J. Fraser Stoddart. Here is the Nobel lecture of Bernard Feringa, given on 8 December 2016 at Stockholm University, while he was introduced by Professor Olof Ramström, the member of Nobel Committee for Chemistry.
Thank you very much. Members of the Academy, distinguished guests, ladies and gentlemen, it's a great honor to be here today. And I thank the members of the Nobel Committee, the Nobel Foundation, and of course the Royal Swedish Academy of Science for this honor given to me and to my colleagues.
Can you imagine that the components of the smallest machine could be molecules? For a machine to function, its parts has to be able to move relative to each other. Bernard Feringa constructed a molecular motor by making a molecular rotor blade continuously spin in the same direction. In the future, molecular machines could be only used for new materials, but also sensors and energy storage systems. In 1999, Feringa and collaborators announced that they had created the first molecular motors. That is a molecule that can be made to spin in one direction. This rotation will set up a tension in the bond that connects the two blades that could cause the other blades to rotate. Each blade had a master group connected to it, so rotation could only happen in one direction. The Feringa group built molecular motors that rotated faster and faster, which culminated in 2016 with the development of one that rotated with a frequency of 12 MHz. The Feringa group used molecular motors in more ambitious objects. In 2005, they were able to spin with molecular motors a classic cylinder that was 28 microliters long, 10,000 times larger than the motors. In 2011, they created a nano car, which consisted of the chassis and molecular motors for wheels, and which could drive over a surface. This graphic picture shows the journal of discovery from the Carroll overcrowded Aikins in 1977. That led to the light-driven molecular rotary motor in 1999. In the presentation of the first electric car, designed in 1835, and the molecular nano car developed in 2011, to the Nobel Prize Museum in Stockholm. The development of molecular motors arguably by offering a fine starting point for construction of soft, robotic, and smart materials and molecular machines. Their ability to design, use, control motor-like functions at the molecular level sets the stage for numerous dynamic molecular systems. This picture shows the first generation light-driven rotatory molecular motor and 4 stages of the rotating cycles 1, 2, 3, 4. Rotary motion is achieved, fueled by light energy, showed control over the directionality, and its repetitive rotary process. Starting with the synthesis of function, their focus was to program molecules by incorporating responsive and adaptive properties and being able to control motions. Molecular information systems, responsive materials, smart surfaces and coating, self-healing materials, delivery systems, precision therapy, adaptive catalysis, removing sensors, soft robotics, nanoscale energy converters, and molecular machines are just a small fraction of systems. Where fantastic discoveries can be expected. Build the art of small will have to reach out to new levels of sophistication when dealing with complex dynamic molecular systems. Well, try to image the unimaginable. Nature's models and machines can, to some extent, guide to molecular explorer. However, at the start of the next journey, they shouldn't forget the words of Da Vinci, where nature finishes producing its own species. Man begins, with the help of nature, to create an infinity of species. Professor Feringa had good collaboration with China. On May 13, 2019, Professor Feringa has invited to Shanghai Organic Institute for an academic visit and give a lecture entitled Exploring Catalytic Space. More than 300 scientific researchers participated in the academic activity. In 2018, Shanghai issued permanent resident identity cards and residence permits to 7 foreigners, including Bernard Feringa. So for today's class, I have introduced you a great scientist who has turned science fiction into reality, who is Bernard Feringa. I hope you enjoy it. Thank you.
大家好。诺贝尔奖评选委员会指出，这3位科学家研发出了世界上最小的机器——分子机器，只有人类头发的1/1000分之一大小。它可以是微型起重机、人工肌肉和袖珍马达。这3位科学家对分子的可控运动进行了优化。当注入能量时，分子能执行任务。费林加则是分子马达第一人。在分子马达的基础上，他成功让一只比马达大上10000倍的玻璃杯旋转，还设计了一辆纳米车。费林加教授指出，探索源于对身边的事物保持好奇心。他谈到自己从小就对身边的环境充满好奇，在不断追问为什么中启发思考。科研的探索的根本是学会 观察、思考和提问。当有人问到为什么需要分子马达的时候，他以飞机的发明和使用做比喻。1903年，莱特兄弟发明第一架飞机时，也不曾预料到100年后的今天，飞机被广泛用于交通工具。这个事实告诉大家，做科研不要带有过多的功利心，要享受自己当前研究领域的魅力。或许它未来的发展前景会远远超出你的预期。好了，本次课到此结束，谢谢大家，再见。